Okay. Hello, stream. How are you doing? It's me, Daniel Duan, and we're gonna work on some more of the library we've been working on in the past few days, okay? And today I have a very specific goal in mind, so that's usually a good thing. And we'll see how far we can get to it, okay? We'll see how far we can get. So we'll start with our on this Mac machine. I think I'll close a few of these because so far they have not been helpful. Yeah, so the last stream we worked on this commit with implementation for metadata retrieving for Windows. And, I was thinking what makes a good tech demo for, the progress we've made so far. We've been building this cross-platform, no dependency, no third-party dependency library for file system APIs for a long time. What makes a good demonstration of progress, right? So we're able to retrieve a metadata for an individual file now. So what if I could also list the content of a file? Combining these two functionality, we can build something like a file browser, right? It's like an LS, even essentially. We can build a command that's like this, right? That shows you a bunch of stuff. Yeah, and that seems pretty cool. And the cool part is a demo that works across platforms, right? That's the really cool and fun part. So today I'm going to work on the API that helps you list the content of a directory, and we can get first the just listing the content of a single directory, and then ideally we can also get to the recursive part. Yeah, so that's the goal. So I'm going to call this branch children because that's the API I like to call this functionality for. So let's jump right in. So yeah, so children is definitely not something you want to implement for pure path. So let's just straight up implement for path plus POSIX. I'm hoping this is possible. Yeah, so far we have working directory. Yeah, let's just work on children. Okay, so there's gonna be a function named children, and it's gonna give us a list of paths. List seems reasonable, and then children will take recursive. Oops, recursive bool. Default is false. So, yep. So I think in the current iteration of the library, the children API also takes another parameter. Okay, so let's take a look at children.swift. I'm gonna just steal for myself here and try to get over the POSIX part quickly. Yeah, so we have children in path. Oh, actually, it doesn't take a file type. It does return a file type. That's interesting. It does return a file type. So this reminds me of something. Yeah, so returning file type, I bet, is a design that. Wait. So there's children in path, and then there's children in path of type. So of type doesn't return file type. So I wanna think about this, right? So should I return file type? Is a little bit unintuitive, but in the meantime, I bet there's a really good reason for this. So when you take a result, you get the file type. Because you're using read_dir. Okay, you get the file type anyways when you get read_dir, because you get the entry of it. Okay, I know for a fact that on Windows this is very similar. So file type is almost like it's almost free, right? So let's read a little bit about the documentation. read_dir. read_dir is a C function, and it returns a dir int. Okay, dir int. Where can I read about dir int? Open dir. Dir int. Okay. So dir int has the inode of the file, and then it has the length of this record, the type of the file, and name. And that's it. That is it. This is when 64-bit inode is not enabled. When it is enabled, we get the file number of entry, the seek offset, length of this record. Okay, so you do get file type, but not much else. So it's almost like, why not, right? Just to return it anyways, and then let user decide whether they want to use it. That makes sense. You know, it is a counterintuitive, but it may come handy for some. So let's make it so. So instead of just a path, we'll also include a file type. Okay, file type again is a protocol, and yeah, it's a protocol. Yeah, this is actually nice. Imagine when we're building the iOS app, we can just use it directly instead of doing some other stuff. But although I probably need to call metadata to get the things like the size and the modification time and stuff. Anyways, let's just take this and see where we want to go next. Okay, so we just read the code as we go. We start with a list of results. Then we try to open the directory. So here I probably need binary string, because it is the path. dot C string. So that's a stream pointer. Why did I call it a stream pointer? I guess this is how that works, right? You get it's like a stream beginning. It's a list. So whenever you call reader, you get a new entry or something. Okay, so system error takes the error code. Okay, I'm gonna pause here and fatal error. And the reason for that is I noticed LSP is struggling a little. So let's do a debug build. Oh, funk. Path plus POSIX. Funk is no fun. Right, it's not path, it's self. Unused warning, throw. Throw is not handled because we didn't declare that, so let's declare that. Throws. Nice. Even got a little bit of formatting action going. POSIX. Okay. Okay. So this is all good, simple stuff. And then we go to the iteration of the stream. For each one, we grab the entry. Entry has a name. We bind it. This is a little awkward. Let me see what's happening here. So entry obviously has a D name. We convert it into unsafe byte. And I assume our goal here is simply to just get a string out of it, right? So can I make this simpler by doing like guardlet name equals entry dot d name. I'm tempted to use Xcode for this because that LSP response is a bit slow. POSIX. Let's see how things fare here. Let's make a build. Show our red stuff. Just to, make it green again. Do it this way. Right, file type cannot be constructed because it doesn't have a... Oh, yeah. No problem. I want to construct a POSIX file type though. And then raw file type. Full name. So you need to join, what is name? Name is a string. So we're joining, so pass joins name. Joined with name. Yes. Why are we returning a string? Recursive. Right. This obviously should be a path. Then the path type. So here we should say is directory. Okay. And then we do full name is an awkward word. Child, maybe. Child. And then here we just do child.children recursive true. Okay, in theory this could work, but again, this is a little awkward because all we're trying to do is get the dname into a string, right? This must be some past Daniel mistake, so let's fix it. So dname, we get, oh, that's why I need to do it, because dname is a, okay, so now it actually makes some sense. We can bind, I think bind with unsafe bytes. Do I need to do this? I feel like there's this has already been done a few times. So let's look at, I imagine binary string should have something like this. Maybe not binary string. If not binary string, what would it be? So current working directory, maybe. Maybe this. Feel like it is in binary string though. Let me just browse this a little bit. Cause what? There's something on Windows that gives us the tuple value as well, and we have to deal with it thusly, accordingly. And it assumes, like, involves like treating things as raw bytes and stuff like that. Is it not in this state of the code base? Feel like it should be something with Windows. It's metadata, so definitely not. Maybe it's something I did during the exploration of things. Okay, that's fine. Ignore. So just think from the first principle, I guess. So we're taking the D name, right? Which is which is a big fixed size array almost. And then we take its bytes, and then we use this. We bind it to, we would do char at least, or rather Unix POSIX encoding unit. And then you take the base address. Come on, you know what? This is fine. This is fine. Pass Daniel, you did okay job, right? We'll just organize the code a little bit. So we guard this and that, else. All right. Okay, this API is a little atypical. Okay, so and also if it's this too special value, we just ignore it from the result. Okay. Okay, so we pretty much just took the whole thing. Let's see how it works. Let's actually work on our example app, right? So this is metadata app, which is kind of similar to what we're gonna do, but let's just make a new one, iOS or something. Yeah, and then let's make a file in there, main, import pathos, and then it's literally just, I guess we can just write the body, right? Write the body. So I guess we just do the same thing with the preamble. Let's do a follow link option here. And then, then we just do a do block, do catch, let error, print error. Okay. So what do we do here? We definitely want, so we have command line dot arguments 1. That's the actual input, and then we just convert that into a path. And what we want to do is take the children, right? Children. Children. I guess I don't want this at first. Definitely want to do a try here. Then let's just iterate over the children. Doop, boop, dump. Because children is a tuple, right? So we'll get file name and all that. And then we'll have to all edit this. So essentially there's this one, we just copy it and say we have a new target called ls. It depends on pathos and its path is ls. Now we can swift build, swift run ls dot. Children is internal. Okay, let's fix it. Let's make it public. Okay, so we got some stuff. So that's promising. Does look like things have correct value. So let's try to make it a little more fun, right? I want to basically replace the metadata demo with this one. So we now have the path for each children. How about we print some information about it? So let's get the metadata. Child.metadata. Right. So really we're getting the child and type. And then we got the metadata. And then we can say something about it, right? So what do we want to say? We want to say, let's see what does ls. So we start with permissions. Meta dot. I just do it in a template. Meta dot is read only. If it's read only, we say read only. Otherwise, we say read write. Yeah. Align this properly. So that's the first column. And then what else is in metadata? Right, there's file size. There's group number and all that. Okay, let's put in file size. How do I pad a string? Is there an easy pattern to pad a string? Swift pad a string. Left pad, let's go. Padding a string. I bet it's just some implementation. So they're using string.padding. Is that a real thing? I've never used this. So we have a value in here, right? Let me, let's do this. Permission is this, but how about I do it like this? Is padding a real API? Or is that part of Foundation? Because Foundation is a big no-no. So this guy is like reverse padding reverse. Stir.padding. Are you serious? It has to be a Foundation API. If it's a Swift built-in, I would have known. Yep, it's Foundation. I knew it. Okay. So what do I do? What do I do? So padding basically is like you have a length, and then if it's all right, I'll just implement it, right? Extension string left pad left padded or with left pad. Do I want left pad or right pad? Left pad. Here's the number. Return another string, and then all we want to do is like pad length is the max of 0 and self.count minus n, right? And then we just literally string repeating space with n with pad length plus self. That's easy clap. I guess pad length, you can just like one-liner this. So easy. Okay. All right. So so this is like dot left pad with left pad of read write dot count. It's fine. It's a demo app, you know, who cares? And then, so that is permission. And then we want to put in, I guess, file size. Size is meta.size with left pad, I don't know how many digits, 10 digits. And then we just print it here. And then I guess we'll show some kind of time. What is this time though? Is this modified time? I don't know. I'll just display a random time. How about that? Meta, guess string. Accessed or modified. Seconds. Dot meta modified nanoseconds. And then probably should make that modified. Just make it nice. And then we include the name here, right? Oh, I guess also file type. Description. Yeah, I guess this is good enough. And then the type. Where should I list the type? The type is kind of, I don't know. File type is okay. We just make an if meta file type is directory, file type directory. Else if meta file type is a symlink, file type would be symlink, otherwise it's a file. Okay, and then oops, where do I put? Yeah, I'll just put it here. Put the file type in the front. It's going to be file type pad with the left pad, the directory dot count. I guess that also means file type length is directory dot count. So we just pad them here. How about that? File type length. Okay, so now I can just say file type. So everything should be nicely padded. File type, we say file type, we say permission size for each of the children, right? Yeah, we don't need a type here. That became obvious. Although we could just use the type. Oh, we can't. Is directory type. Okay, that's fine. All right, let's run it. Let's run this. Oh, the padding does not work at all. What the heck? Oh, I messed this up, didn't I? N is bigger usually. Okay. How about now? Nice. That's something. Although, looks like the time is not super nice. Should I pad the time? Do modified with the left pad. I don't know. 20. Oh, 20 is remarkably close. About 24. That's something like a ls, right? Directory, file, read, write, read, write, read, write, read, write, blah, 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 blah. And then that's the actual output. Nice. I like this. So how should I proceed? Let's first checking our code for the children implementation. Oops. Looks like we got auto formatted. Yep. Things look a little weird, but I dig it. Oh no. I realized something. My hook is wrong. Let me just disable this for now. I was like, you know, if you have git diff, don't let me commit. But that's obviously not what I want here, for example. Okay, implement pass.children for POSIX. Okay, and then we added the sample app. Add ls example app. Okay, push this up to the repo. Doing okay. And it took us 40 minutes to get here. 40 minutes to copy some code. Let me just throw up a pull request here. It will fail, but that's okay. We won't wait for that failure. Implement pass.children. Okay. Okay, so basically next we want to implement this API on Windows. Yeah, I can roughly give it a go, I guess. This will be like blind implementation because obviously I'm using a Mac OS machine. So let's just sketch out the rough shape of the code. It might be difficult if it gets there. Well, it's not like going on Windows will help me. Anyways. Okay, so let's implement the same signature here. Pass plus POSIX has this children thingy. Wait, did we do anything about being recursive? Yeah, if it's recursive and the path type is directory, then we get the children there and add it to the result. And the result is a flattened result. Nice. Okay. Again, I'm here for this. Let's go to path plus Windows. Implement it, I don't know, here, middle of the nowhere. Okay, so we're gonna use this find first file thingy. I just realized something. Whenever I'm writing something on Windows, I don't actually close the file handle. That is unfortunate. I need to fix it. Let me file an issue so that I don't forget. Window file handles aren't closed in probably more than one places when we obtain a Windows file handle. We don't close them with close handle. As we are expected to. Okay. That is the issue. All right. So let's implement that. We're gonna do blah 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 blah. We find the first file with the name. What if the name? I'm trying to see. Children. Find first file. When you find the first file, you also get its data, right? So let's get the data, grab a data here. Okay, so after we obtain a handle, we should also just close it, right? Defer, I think it's called close handle. Let's see. Windows close handle. I bet it's close handle. Yeah, looks right. Okay, so we close the handle. Now let's create the result array. Var result. It's gonna be empty array of this. Give me 1 sec, sorry. Okay. So now we have this data. Wait, what am I trying to do? I'm trying to get the children, right? So I want to find the first one. Should I try to obtain the file type first? Like the first step is self dot metadata dot file type is directory. I mean, at some point we need to check this, right? So I need to guard this, guard else, return this. I wonder what happens if we don't. Well, let me check. Let's check from the implementation. Like, I wonder what the POSIX implementation does. POSIX, I guess opendir will just fail, right? Yeah, I wonder if opendir fails. So what I'm wondering is like, what happens if I use this on a non-directory, right? So Swift run ls package dot. So this just gives me an error 20. POSIX error code 20 is not dir. Okay, makes sense. Makes sense. So I'm assuming find first dir will not fail, or find first file w. This will not fail if it's a directory. The directory or path and the file name, blah, blah, blah. The parameter should not be null. Valid string or the backslash. If this ends with wildcard, period, or directory name, the user must have access permission to the root and all. Blah, blah, blah. If then, okay, return value. If it succeeds, return value is search handle using subsequent call to find next one and find close. And the find data parameter contains information about the first or directory found. If the function fails or fails location from search parameter, there's a file handle, and then you can get the error. Okay. Return information in the first file that the file finds with the name that matches the specific patterning. This may or may not be the first file directory that appear in a directory listing application, such as the dir command, when given the same file name string pattern. This is because find first file does not sort. Okay. The following list identifies some other search characters. The search is performed strictly on the file, the name of the file, not on any attribute such as date or file type. The search includes a long and short name. An attempt to open a search with a trailing backslash always fails. Passing an invalid string null or empty string for the... Okay. After the search is established, you can use it to search for other files that match the same pattern by using find next file. Do not use a trailing backslash in the string, therefore it may not obvious how to search root directories. If you want to use the following options would apply. To examine files in root directory, you can use this with a star and step through the directory by using finding next file. Okay. So it looks like we're gonna need a pattern for this. So if your input is a directory, find first file of the directory. What would that do? We know that we can find, when we use find first file, we can get information about the metadata of the directory. I never tried find next file. That's the interesting part. So I never know, like, if you, let's say the path is a folder, and then you call find first file or return information about the folder with a handle, and then you call find next file. What happens, right? And from reading this, it's not super obvious. Could wildcard characters. A pointer to the when finder to structure that receives information about the found file directory. Return value. Return value is a search and using something called find. Let's read find next file. Continue search for previous call to find first file. The handle and then the data. Return value. If it succeeds, return value is non-zero, and the contains the information about the next file directory found. If it fails, mark this function use the same search filter that we use to create the search handle passing channel parameter. Find first file in order to which the return file, such as alphabetical order, is not guaranteed. Okay, the order in which the return file needs to depend on the file system type. I don't care about the order. I do care about what gets returned. List files in a directory. Let's go. Find first file. Okay, find first file gets this. So it looks like they did add this towards the end. Okay, so that's what I'll do. Easy. Okay. I wonder if this is still necessary. Let's skip this for now. Skip this for now, like so. And then we'll do self plus star. Binary string. Okay, we get the resulting data, close the handle, and then we'll just print out the data. So the data, let me think. We can definitely get the metadata. Metadata has a, oh, this is awkward. We take the data, we get the metadata, and then we can return data dot, I guess it's here as well, but what's the name? C file name. String. No. Windows binary string, C string, data.c file name, and then dot, I guess this would be the path of the children. or rather, I don't need all this. I can do this. Okay, so this give me the path. This give me the metadata, and that is our result. Okay, we'll just return this for now. The first result. And we'll package it up into a tuple. Okay, so that's the result. We won't know whether it's correct until we try it on Windows. So let's do that. Oop. Implement Windows. Formatting happened. Stage this chunk, okay. All right, you guys ready for some exciting Windows programming? Did you see this coming? Let's switch things. All right, here we go. I'm gonna go to source one, pathos, pull, check out children, and then can I just wait? Codegen. Oh, okay. So we can just build here. Is this the first time C file name gets used? Okay, slightly annoying, but we'll get through this. So C file name again is a tuple. So this is where I can do. Wait, let's write it in here. Okay, let's go back to the Mac and then let's convert this into the thing we expect. Let me read this a little bit real quick. Find file data. Find data W. Win32. Win32. Find data W. Okay. Okay, so it is just a W char array, except we have to deal with it. So we have to do like I don't know, like so you start with what, unsigned int 16, right? Unsigned int 16. What is the right API to call here with bind? I feel like it has the word binding it, right? Bind with unsafe bytes. a dot with it's gonna be with onSafe pointer. Bind, no. And working with pointer is very interesting. It's always very fascinating, but also I forget what to do every time. With memory rebound. Oh, thank you very much. Okay, so we first get the onSafe pointer, and then we bind its memory to Windows encoding unit. Capacity is max path. Okay. Now we're cooking. Okay. So in here we can finally say pass C string $0, I believe. I should really edit this on Windows, because there's no point writing this much code without testing. Okay. I know some type is not working out in there, but since we don't have syntax highlighting, just do this. Okay, and then we'll switch scene. Come here, and we'll learn what we did wrong. And this time I won't switch back. Okay. Path plus Windows is what we're interested in. Let's fix these mistakes. Let's fix these mistakes. So this should be an int. This should be a lowercase p. Metadata dot file type. Oops. And so we need to unwrap this. That's not very pleasant. Right, so it's not that. Oh, wait. What am I doing here? This should be .c string, right? Oh, we built. Let's see what happens. We're supposed, if everything works, we're supposed to see at least one child of an input. ls. Do we have an ls? Oh, we don't have ls, so we need to fix that as well. Fix that. So here we need to add a new target. Call it ls. For some reason, ls reminds me of Los Santos. Okay. Is this good enough? I guess we'll have to reconfigure a little bit, and then we build. And then we run. What do we run? Build then ls. What do we do? Do this. How about this? Uh-oh. What is error code 2? Probably something simple like no such file or something. Windows error code. Error code 2, file not found. What if I skip this part? Oh, this is something. Okay. What if I say straight up take self binary string, C string? It still says file not found. And I assume the error is from here, right? No, it's not. Is it? Wait, things are proceeding. Why does it say file not found? It must be part of the sample program. Hold on. Let's see. Oh, file not found indeed. Why does the first file... Okay, interesting. What? How did you find recycle.bin? It must be reading from the root, right? Description. Maybe there's a bug in path joining. Wait, that makes no sense. What? What? So this plus operator is obviously wrong. Darn it. How is that possible? Let's go to source. There is a path plus joining. Okay, so what we're doing here is we're adding path, which is none of these. So is it just in here? No. Okay, so we're supposedly calling this, right? Just to make sure. Okay, we are calling that. So this is calling joined with is pure dot join with. So Windows pure Windows path joined with others. So let's print these out. Let's see what happens. Yes, of course. When you join a normal path and a root path. Oh, silly mistake. Everything is working as designed. It's just I wasn't paying attention. That's so silly. Okay. So we're joining a path with a path with another path with that's absolute. So the absolute paths take over. So what we really want is just this. Yeah. Okay. That is very interesting experience. Oh, we got something. What if it's a file? Okay, file, give us an error. That's perfect, actually. Right? Let's, just to make sure, try another input. Sources. It's a directory, read write. What is 0? 0 is size, right? Okay. The path is a little wacky, but we can deal with that. Okay, we got something. Good. Okay, so far we've got one of the paths, right? The first path specifically. But we also got a file handle, which is really good. So let's just tug this result in. Oh, well, let's see. So here we actually care about the file name. I just realized some inefficiency in here, but we'll deal with it later. First, we'll append this result. And then we will I guess find next file W. Give it our handle. And then I'll read the find next file documentation here. And yes, find next file. Just give it the handle and the data, right? Yeah, and then I think it returns the bool. If it succeeds, is non-zero. Non-zero. Okay, so I guess we'll just do while this we just keep repeating this, right? We get the path, we get the file type, we append it, and eventually we return the result. Is this good? We good? Looks good. We've got a bunch of results. What's getting printed here? What? This is getting printed. Okay. So how was the result? That's an error. Let me just rebuild it. It's a little annoying, the debug value. I see. So the result actually is incorrect. So this is where we need to filter things out, okay? How should I do this? So here is like if result, if path, description. I hate doing description. How about path dot binary string isn't equal to after constants dot separator, right? Constants, Windows constants, separator byte. Really should rename that, but constants separator byte. Constants separator byte. If either of these is the first result, we append it. How about that? Does this compile at all? It does. Wait, what? Did it compile? I thought I excluded this guy. But apparently I didn't. Also, all these brute force manipulation of paths, binary string paths, makes me want to rethink about exposing it directly, the binary string abstraction at all, to user. Maybe it's a nice idea, but not very practical. Anyways, okay, I'm gonna actually print it out. Okay, print path.binary string. And this. So we know they're not equal, but what are they, right? Let's look at it. One is 46, one is 92. Oh, right. Separated byte, of course, is the wrong character. What I meant is current directory byte. Sorry, very sorry. I'm so sorry. Current directory byte. Okay. So this should filter that one out. Yeah. And then we need to do the same thing here. Okay. Now this will give us an empty result, which is not a bad thing. And then also there's quite a bit of repetition here. Maybe let's see, the input is a path. Well, really the input is data, right? Okay. Let me write an internal function here. Add result if necessary, and our input is the data object of type this. How about we make it a reference? Okay. So what do we do here? We just execute this block of code, really. I think we can capture the result value here, so that's no big deal. We try to create a path, we get the data CNAME, we encode it into this path object. I mean, everything here is okay, except at this point, I already made a copy of the CNAME buffer. But I technically don't have to, right? I can do something like if data.cname c file name dot zero is constants dot current directory byte, and well, and then if data dot c file name dot one is the same, or data.c file name dot one is 0, this is good enough for me to just return. Then I don't have to worry about that again anymore. Okay, no more printing here, no more worrying about that. Yeah, and then I can convert this thing, into metadata and add it. Okay, so the only thing that's left is that the value in this data, in this C file name, is actually incorrect. So let me revisit the binary string implementation again real quick. So in binary string, we can take Yeah, we can take an unsafe pointer. Right, we can take an unsafe pointer here. Okay. So maybe what I want is a Windows binary string. Okay, and call this binary. And then the actual path is path created from self.binary string. Oh, actually it's just simply self.joined with binary. Okay, so this is much better. And then here I can simply just say add a result if necessary, data, right? Then same thing inside the loop, no more repetition. I wonder what this does. Code definitely looks much cleaner. Right. No need for this. Ah, much better, right? This does look like the current content, the content of the current directory. Yeah. Okay. So that's pretty nice. Yeah, I guess the next step is we have to we have to do the recursion part. Let's see. So we need to grab the metadata out. Get metadata. Let meta equals metadata from data. Okay. So here we can simply just say meta.file type. But before we do, we return, we will say if recursive and meta.file type is directory, then we have to append result. Result have to be enhanced with path dot children recursive true. Okay, so this is where we can go back and fix this part. I don't think this is too big of a change to break things. Yeah, we need to throw that thing. Okay, throws. Right. Add if necessary. Try that. Try this. Nice. Okay, so how do we test recursion? It's gonna be a little tricky, but we'll just hack it, okay? Let's just hack it. If command line arguments count. Command line arguments count is greater than 2. Greater than 2. And command line arguments 2 is -r. Well, we'll just call that recursive. Okay, and then when we do this, we'll pass that in recursive. Oh, this is fun. Let's see what this does. Okay, so this is still the same input. Now I'm going to add -r. We got quite a bit of stuff, but I think the output looks more or less correct, right? Oh, we got the entire content of the Git subdirectory. That's not super helpful. So let's look at a smaller directory like sources. Sources, we've got a bunch of stuff. Yeah, I like this. This looks right. Nice. Examples. What did I do? Add recursive option. And then for this example. And then the main changes in the source. Actually, one thing I really am curious about is this. Symlink. Man, we spent so much effort to do this. I hope you remember that. Yeah. Feels good, man. Feels good, man. Okay. Implement children pass.children for Windows. Nice. So now what? I think we're done. Let's organize our commits a little bit. Oh, let's do it on the other computer. You ready? Let's switch. Ba-boom. Okay, so I just want to do some file, I guess, commit organization. Branch set upstream to origin children. Okay. Now let's pull down the changes. We'll take a peek. So we definitely want this commit. We definitely want this commit. We definitely want this commit, and the rest of the commits can go here. Unless. Let's just rebase interactively. Let's see if we can first. We'll keep this one. We'll keep this one. Can I just reorder before anything? Okay, that works. And then we just squash everything for the Windows implementation. That should be okay. CodeGen, does this do anything? Oh, we got a formatter changes. Deleted some implicit self. Okay. I guess at the end, how about we delete the old example? Examples metadata. This was a good example at its time, but we've got a better one. So adios. Packages. Metadata can go away now. Hope this doesn't change anything. Okay. Delete metadata example. LS covers it well. Okay. Now what? Yeah, now I want to write a test. Let's actually write a test. Okay. Again, this is not going to be a super comprehensive test in any way. It's just going to be something that checks, like acts like a sanity check. So here, children tests. And we're going to begin by importing our library and XATest. Children tests is a test case. And then test children of current directory. And what we do here, I guess we'll just say XATest case, or XAT assert no throw path, right? And then we make a path from current directory and then ask for its children. That should pass. Okay. I guess we'll try a recursive one as well. Recursive true. Okay, so that kind of worked out. We'll update our test manifest and CMake list. Nice. Add sanity check for passed out children. You notice that that test is agnostic to platform. So if we switch back to Windows, let's do that. Switch to Windows, right? And then we will first rerun CMake. To do that, I do this, and then I can run test. And we ran 77 tests. I'm always curious about this. So there's a test executable, Windows main, I believe. Can I just give it like children tests? I feel like this is something that should be possible. So path, so definitely possible. I did it yesterday, right? So this could mean it's not in there. Hmm. Oh wait, did I pull? Probably didn't pull, did I? Reset hard origin children. Then we can do the everything above again. I remember the last time we ran 77 tests. So this time if it's 78, we have a pretty good confidence. Actually, let's run this. No, that didn't work. How about this? Oh, we didn't build, so that didn't count. We'll try that again. 79 tests. And now, wait. What? Did I misspell children or something somewhere? Tests. Child ren tests. Child ren tests. Oh, why doesn't this work then? Oh, pass those tests. Dot. Okay, there we go. We ran those two tests, and none of them, neither of them through. So that's really good. That's really good. Okay, so I don't think I made any changes here, right? So I can just go back to the pull request. Wait, something failed on Linux? The one platform I didn't test. Oh, it's this again. That's annoying. Okay, so we've dealt with Mac OS, we've dealt with Windows. Now we have to deal with Linux. It's pretty interesting. Binary string, C string. How did I implement this? Okay, apparently with unsafe buffer pointer, C string. It is optional in signature. So path plus POSIX. Abort. Is it in here? Okay. Okay, so this guy is a optional value. So I can, I guess, unwrap it. Binary string dot C string. Does this work here? Okay, if it works here, it should work anywhere. Unwrap C string before in children implementation. Okay, the good thing is the Windows Linux tests takes very little time to run. So hopefully we'll get, well, actually there's an even better thing. We can just run our tests in Docker. Okay, we passed the tests. So I think we're good. I think we're good. All right. That went really well. I think I'm gonna end the stream here. Call it when it's still good. Nearly 2 hours, almost. All right. Thank you so much for watching. Again, I prefer you watch me on Twitch. So if you're watching elsewhere, please consider give me a follow over there. If you're watching this on YouTube, give this video a like. Yeah, definitely subscribe to my channel. And I'll see you next time.